we are going to talk about two different types of special right triangles. The first type of special right triangle is called the 45, 45, 90 right triangle. And it's called that because the angles of this triangle will be 45 degrees, and 90 degrees. If we have two angles that are 45 degrees, remember from previous lessons that if two angles match, that means two sides are also congruent. And so that means it's an isosceles right triangle. So even if you only know about a triangle that does not look like a right triangle, but pretend like it is, if you only know that it's an isosceles right triangle, so isosceles meaning two sides are congruent, right meaning there's a right angle in there, we know that that is a 45, 45, 90 right triangle. So as long as you can recognize that something is a 45, 45, 90 right triangle, then something cool happens. First, we know that the two legs are congruent. We know it's isosceles, I just mentioned that. And then we can find the hypotenuse, and you could use the Pythagorean theorem, but a shortcut is that the hypotenuse is just going to be whatever that leg length was times the square root of 2. So I'll show you what this looks like in practice. I'm going to start over here with this square. We know all the sides are congruent. So if I just take one of those right triangles for a second, because these two sides are each 8, I know this is an isosceles right triangle. And if it's an isosceles right triangle, then that means these angles must be 45 degrees each. So we can use that rule. Instead of using the Pythagorean theorem to get that hypotenuse, instead we can just take 8 times root 2, or we would just call that 8 root 2 as that diagonal length. In our other picture, we are given the hypotenuse and we know that it's a 45, 45, 90. It's a 45, 45, 90 right triangle. We know that, again, because these two sides are each marked as x and x, which means it's isosceles. And if it's isosceles, then each of these angles is 45 degrees. So this time we are given the hypotenuse. So instead of multiplying by root 2, we're going to divide by root 2 to get the leg. So if I took 2 root 2 divided by root 2, my answer is just 2. So each of those side lengths would be 2. So here's some more practice with the same idea. In the first picture, we know it's a 45, 45, 90 because of the 45 and 90. We know the third angle has to make the angles of the triangle add up to 180, so it must also be 45 degrees. Because it's a 45, 45, 90, we know it's isosceles, so this side length is also 8. And we're looking for the hypotenuse. To get the hypotenuse, we just multiply by root 2, so 8 root 2 it is. In the next picture, we know it's isosceles because the legs are both labeled as x, and x. Because it's isosceles, it's a 45, 45, 90. So to get the side lengths, we are going to divide by root 2. So each of our side lengths would be 5. The last picture is the trickiest of them all. We can clearly see that it's a 45, 45, 90. We're given the hypotenuse, but this time our hypotenuse does not have a root 2 on the end. If it did have a root 2, then by now you probably can just recognize that those two side lengths are going to be 10. But it does not have a root 2. But we're going to go through those same steps that I took you through on the last problem. Think of it as dividing by root 2. So we're going to take 10 divided by root 2. And I'm actually going to write this down here so you can see it a little bit bigger. You might remember from algebra class that we cannot leave our answer like this. We cannot leave it 10 divided by root 2 because we have an irrational number in the denominator. So we have to rationalize it. If you forget how to do that, what that means is we are going to multiply the numerator and the denominator by root 2. So we're going to multiply by root 2 over root 2. We're allowed to do this because root 2 divided by root 2 is just 1. So basically, we're multiplying by 1, which is allowed because it doesn't change the value of our original term at all. So when we multiply the numerator by root 2, we get 10 root 2. When we multiply the denominator by root 2, we have root 2 times root 2, which is root 4. And the square root of 4 is 2. That's why we went through that process, so that we would not have a radical in the denominator anymore. Now I can go ahead and simplify this one step further by taking 10 divided by 2, which is 5. So my answer is 5 root 2. So each of these side lengths would be 5 root 2. Okay, now we're going to talk about the other type of special right triangle, which is the 30, 60, 90. So here's kind of our cheat sheet, just like for a 45, 45, 90. It was that if you know the legs, then the hypotenuse, you just multiply by root 2. But for a 30, 60, 90 right triangle, so they could look different, but you'll always have one angle that's right, that's a 90-degree angle, one angle that's a 60-degree angle, and one angle that's a 30-degree angle. I'm going to label these sides down here so that you get used to me saying them this way, but I always call the side across from the 30-degree angle the short side. If you remember from a previous lesson, the smaller the angle measure, the shorter the side that's across from it within a triangle. So across from the 30-degree angle is the short side. Across from the 60-degree angle, I'm going to call that the long side. And then because it's a right triangle, the side across from the 90-degree angle, I'm going to refer to that as the hypotenuse. So in our little helpful picture over here, we have a 30, 60, 90 right triangle. So across from the 30, that's your short side. That's the side we want to know. So if ever you don't know what the short side is, that's the first side you want to find. Find this side, because if you know the short side, the other two sides are pretty easy to find. To get the hypotenuse, you just multiply by 2. You'll see over here the hypotenuse is 2 times x, 2 times the short side. Remember, x represents the short side. And to get the long side, we take x, or our short side, times root 3. So in this first picture off to the right, we have a 30, 60, 90 right triangle. We can see the 30 degrees and the 90 degrees, which means the one that's missing is 60 degrees. And in this case, we know the hypotenuse. Our hypotenuse is 16. But I told you that it's helpful to know the short side. So because the short side is missing, that's the first side we're going to find. So let's look at this little diagram to help us out here. Our hypotenuse is labeled with a 2x. Our short side has an x. So in order to go from our hypotenuse to our short side, we need to divide by 2. So if our hypotenuse is 16, that means our short side is 8. So if you know the short side, you're going to multiply by 2 to get the hypotenuse. If you know the hypotenuse, you're going to divide by 2 to get the short side. And it'll work similarly with the long side. We'll get to that in a second. So in this case, our long side, now that we know the short side, our long side is easy. We just multiply by root 3. So our long side is 8 times the square root of 3. So let's get some more practice. This picture off to the left is just a reference for us because this one's just a little bit more complicated than the 45, 45, 90 right triangle. So in this picture, we know the short side. That's good news. We want to know the short side. If we know the short side, the other two are fairly easy. To get the hypotenuse, which in this case is c, we just multiply by 2. So our hypotenuse is 2 times the short side. So our hypotenuse in this case would be 10. Our long side is the short side times the square root of 3. So in this case, our long side would be 5 times the square root of 3. And another example. This time we do not know the short side. We know the long side. The long side is the most complicated because it's the one with the radical. It's the short side times root 3, but there's no root 3 here. If it did say 9 root 3, then to get our short side, we would just ignore that root 3 and our short side would be 9. But it doesn't have a root 3 there. So to go from our long side to our short side, so we want to make the number smaller because the short side is smaller than 9. So we're going to take 9 divided by the square root of 3. And just like we did with the 45, 45, 90 triangle, we need to rationalize this denominator. So we're going to multiply the numerator and denominator by that root 3. And what happens when we do that is in the numerator we get 9 root 3. And in the denominator we get root 3 times root 3, which is root 9. And root 9 is 3. So we've rationalized the denominator, but this one can be simplified just a little bit more because 9 divided by 3 is 3. Our answer is 3 root 3. So our short side here is 3 root 3. So all that work to find your short side, but again, once you know the short side, the other sides are easy to find. To go from short to hypotenuse, we're just multiplying that by 2. So we're going to take 3 root 3 times 2, and that's 6 root 3. We're just doubling it. So now let's put all that practice together. So first we need to decide what type of triangle each one of these are, and then we'll figure out what's missing after that. So in this first example, we have 2 sides labeled as root 2, which means this is an isosceles right triangle, or a 45, 45, 90. So if you look at your reference for 45, 45, 90, the 2 legs are the same, and to get the hypotenuse, you multiply by root 2. So we know the legs. To get the hypotenuse, which in this case is y, we're going to multiply our leg by root 2. So root 2 times root 2. Square root of 2 times the square root of 2 is the square root of 4. That's just 2. So our hypotenuse is 2. In the next picture, it looks like we're kind of starting with an equilateral triangle. I mean, it is an equilateral triangle, 4, 4, and 4. But we put that height in there. And so what that height is doing is creating a right triangle. And because in an equilateral triangle, all of these were 60 degrees, this is 60 degrees, which means this is 30 degrees. This is a 30, 60, 90. We know that the short side is 2 and the hypotenuse is 4, which makes sense because we know that the short side times 2 is the hypotenuse if it's a 30, 60, 90 right triangle. And so to get that long side, which in this case is the height of the triangle, we take the short side times root 3, and that's 2 root 3. The next picture is another 30, 60, 90, and we know the short side. Yay! It's good to know the short side because if you know the short side, to get the hypotenuse, you just multiply by 2. And to get the long side, we multiply by root 3. Square root of 3 times the square root of 3 is just 3. So x is 3. And our next picture, this is isosceles. Those are congruent, which means it's a 45, 45, 90, which means to get our hypotenuse, we are multiplying by the square root of 2. So if I take 3 root 2 times root 2, that's 3 times the square root of 4. The square root of 4 is 2. 3 times 2 is 6. All right, just a couple more to go. The next one, it's an equilateral triangle, so all these sides are 36. And we want to find the area of the sign. So all of those are 36. To find the area of a triangle, it's 1/2 base times height. So I need to figure out the height of this triangle. And to figure out the height, we're going to look at half of this. And we know it's a 30, 60, 90 right triangle because the original triangle was equilateral. All of these are 60 degrees, which means this over here is 60 degrees, which means this must be 30 degrees. And we know that the hypotenuse is 18. We know that silly me, got ahead of myself. The hypotenuse is 36, which means the short side is 18, which means that height, h, is 18 times the square root of 3. Because it says the word estimate, when we go to find the area, you could actually type in 18 root 3 on your calculator and get what that decimal is. I don't know what that is off the top of my head. So I'm just going to give the exact answer. So our base was 36. Our height is 18 root 3. And so we're going to multiply 1/2 times 36 times 18. So that's 324 times the root 3. And again, because it says estimate, it probably didn't want me to do root 3. It probably wanted me to actually take 324 times root 3. But I don't have a calculator to do that right now. Last example that I'm going to do with you. This is, let's see, the body of a dump truck is raised to empty a load of sand. How high, so we're looking for the height, is the 14-foot long body. So that means the hypotenuse is 14 when it is tipped at a 60-degree angle. So we are looking, it already labeled the 14 for us. Perfect. So this is clearly a 30, 60, 90 right triangle. I drew it, the reflection of it. Hold on, let me draw it in the same. So 90, 60, 30. We know the hypotenuse is 14. Even though we're looking for the long side, if you don't know the short side, that needs to be your first step. So our short side is half of the hypotenuse. So because our hypotenuse is 14, our short side is 7, which means our height is 7 times the square root of 3.